This is question 9 from the 2023 A2 Pure Maths paper that was sat on the 6th of June, and it's from CCEA. So question 9 involves a bit of Newton-Raphson numerical methods and then a wee bit of parametric differentiation. So let's take a wee look at part A. The graphs of the function f of x equals e to the x and g of x intersect at the point where x equals a, so the value of a lies between 1 and 2. So if the graphs intersect each other, then we want to put them equal to each other. So we have e to the x equals x plus 4. Rearranging that, taking everything then to one side, we're going to have e to the x minus x minus 4 equals 0. And if they sort of intersect, then there should be a solution between 1 and 2. So because this is a continuous function, the signs should change then if we sub in 1 and sub in 2. So whenever x equals 1, we would have then e minus 1 minus 4. And that gives us, if you check that in your calculator, you get minus 2.2817. Whenever x equals 2, we get e to the 2 minus 2 minus 4. Again, sub it into your calculator and you get 1.3890. So because then we have a change of sign, meaning it's gone from negative to positive, x equals 1 and 2, and the fact it's a continuous function, that means there's no gap in it. Sometimes between 1 and 2 then there's like maybe an asymptote or something, and a continuous function, and that indicates a root that's between 1 and 2. Part 2 then, starting with x 0 to 1.5, using Newton-Raphson method twice to find a better approximation for the value of a. So our function then, f of x, is e to the x minus 4, and obviously then we need to differentiate that if we're going to be using the Newton-Raphson method. So that gives me e to the x. That bit disappears, so we just then have minus 1. So Newton-Raphson formula is as follows then. So x to the n plus 1 is x to the n minus, f, x to the n, so you know where I got that from, f dash x to the n. So that means the first term, we're starting with x0, which equals 1.5, then x to the 1 is going to be 1.5 minus, and then my f of x up here is going to be e to the 1.5 minus 1.5 minus 4, all over e to the 1.5 minus 1. Again, put that in your calculator, so you could just about see that there, apologies, and you get 1.792476. So what have we done? We know there's a solution between 1 and 2. We started with 1.5, and by subbing in 1.5, this gives us then a more accurate version of what we need. We do the thing again, so we instead of substituting in 1.5, we substitute in it with 1.792476, and we get then our next term. So I'm not going to write it on here, but you'll hopefully get the idea what's happening. So instead of the 1.5, I'm going 1.792476, e to the 1.792476 minus 1.792476. Take away 4, all over that. You can get your calculator to do it for you. And so the next one, then the 3 significant figures, goes to 1.75. And that's it done twice, which is what they've asked us to do. It says use the method twice to solve then from there. Part B, a curve has the parametric equations x equals cosec squared t and y equals cot t. Find an expression for y, dy by dx in terms of t. So x is then cosec squared t and y is cot t. This one's a bit more straightforward to differentiate. So dy by dt, if you differentiate cot, you get minus cosec squared. You get given that in the formula booklet anyway. This one here cosec t all squared. So then dx by dt, this is the way I do this, and so I kind of bring the 2 to the front, and cosec t, take away 1 for the power, so that then is the power 1, and multiply by the bracket differentiated, so it's effectively a chain rule. So the bracket differentiated then is going to be minus cosec t cot t. So tidying that up, that's a cosec t, that's a cosec t, so I get minus 2 cosec squared t cot t, cot t, and we have that, and we want of course then dy by dx. So that's going to be dy by dt multiplied by dt by dx, so it's going to give us minus cosec squared t multiplied by 1 over minus 2 cosec squared t cot t. We will just, so the minuses are going to cancel, as will plenty of other stuff in a second. Cosec squared t all over 2. So that is going to cancel with that, and then the cot t we can just bring back up to the top then and call it tan, so it's going to give us then a half of tan t.